right, guys. So hopefully you have had a good review of independent variable, dependent variable, setting up data tables, all of which will be part of an assessment you'll have on Wednesday. And now we want to just keep moving forward and reflecting and about learning about the lab that we did with the tracks last time. You'll remember that the people in the front were answering the question, how does force affect acceleration? By creating a bigger pull on their cart. And the back row was studying how does mass affect acceleration by changing the mass of the cart itself. And so these three variables are connected by the equation force equals mass times acceleration. And so I've left you some problems to work on this math. It's not a hard equation, as you can see, but I have given you some examples where you have to find the net force in order to plug it in to find out the variable that you're looking for. So let's look at an example. So this one says, what is the force on a 1 kilogram ball? Okay, so we are looking for force. What is the force on a 1 kilogram ball? So that's 1 kilogram. And it is free falling due to the pull of gravity. Okay, so acceleration due to the pull of gravity. I know I've told you over and over you can use 10, but we're going to go ahead and use 9.8 meters per second squared. Now, a really important thing, and this is right at the beginning of your worksheet here, is the fact, there's a little review here, or intro really, that mass is always measured in kilograms. So if it's not, you need to convert it. Acceleration is in meters per second squared, and force is measured in newtons. So be careful of that as you're working through the problems. So let's look at this one more time. What is the force of a 1 kilogram ball that is falling freely due to the pull of gravity? Okay, so what's the force? We've got the mass, and we've got the acceleration. So you always want to, I've already written this obviously, but you always want to write your equation first. It is not acceptable to do it any other way. This case force is just 1 times 9.8, or I guess I should say 1 kilogram times 9.8 meters per second squared. So the force is 9.8. And what is the unit? Newtons. All right, so there you go. Easy peasy one, right? So let's skip number 2 and look here at number 3. A girl on roller skates accelerates at a rate of 2 meters per second squared, so that's what this means, meter per second, with a force of 100 newtons. So what do we know? We know that her force is 100 newtons, and her acceleration is 2 meters per second squared. Is that right? So a girl on roller skates accelerates at a rate of 2 meters per second squared with a force of 100 newtons. What is her mass? Okay, so if we plug this into F equals ma, we know the force is 100, and we know that mass is what we're looking for, times 2. So to get mass by itself, obviously we're going to divide both sides by 2. And we're going to get the mass is 50. And what's the unit for mass? Kilograms. Okay, so that is an overview of how to do these problems. Feel free to come back and look at this video